Hi friend, how are you? My name is Alex Sebahire. In this session of video we are going to see 3 ways of blinking a LED, of course using Labview. Stay in touch, be with me in this session of the video. Let's of course create a new blank VI by clicking by first stopping this stuffs which is not needed at this moment. Click Ctrl N, then Ctrl T or go to window and tire left and right, but I already finished it, so let's pull this tab over here. Okay, first let us introduce our LED over here. Adjust its size so that it will blink in a way that will show what's the right. So assume that our LED is already connected to a sensor which is varying its voltage between, for example, 0 and 10. So, and assume that the sensor will going to light up the red as a way of giving an alarm to the user when its voltage goes above 10. So let's create a random number which generates a number from 0. Of course, if you click on help and then you click on this, it will show you that it generates a number from 0 up to 1. It means 0, 0.5, 0.3, 0.989, it means all the numbers that are ranged between 0 and 1. So we need to light up, to blink the red when the voltage goes above 8. So for having a perceptible measurement, let us multiply the output of our indicator by 10. Okay, by 10. Create control, create a constant, then 10. So by multiplying the output of sensor by 10, it implies that the output of sensor is no longer between 0 and 1, but it goes between 1 and 10. So let's create like a logic output by comparing the output of sensor by 8. Create constant 8. Let's put it down for having good appearance. So now this comparison operator will perform the importance of changing the numerical value into logical values. It means between 0 and 1. When the output of this multiplication goes above 8, the sensor will output logic high to the LED and the LED light up. So of course this will be in the loop that will have several iterations. Okay, create a control button here for stopping, for the purpose of course of stopping the loop. Pull this stop button over here, adjust the size, and of course I think we can run. So let us create a timing like for waiting the sequence, timing like that of timing of 500 milliseconds. That means the iteration, the time between iteration will be a half of second. It means 500 milliseconds means a half of second. So if we run, will see that our red are blinking. Are blinking. So let us reduce the wait time to, for example, 250, a quarter second, then run. You see that our radar is blinking. This is the first way of blinking red. So let us go to the second way of blinking red. Let us, of course, remove this loop. Remove the while loop, because of course this button. Of course this timing is gonna change. Let us make like this and change this. Second way of blinking red is by using sequence. It means the red to blink, it is the sequence that alternate between high and low. It means true and false. So let us create a sequence over here, a flat sequence. Draw flat sequence a little bit here. Click here, left click, add the frame after, adjust it size. It means we will have two sequences, true and false. So here you create a local variable. Local variable is, of course, as you know in C, local variable helps us to access the object. Ctrl Z to undo. Local variable helps you to access the variable inside and outside of the loop. Press our local variable here, left click, change to read in order that our local variable work like an output, of course by reading what we are going to program over here in flat sequence. So copy this over here, then change to write. We are going to write something on our local variable. Change to write, then create constant over here. Of course the constant will come as logic value. It means either false or true, but by default it comes as false. Copy this and drag this to the second, to the first, then pull this, select, pull this to the second sequence, and of course we draw the for loop. Okay, let me show you the difference between for loop and while loop. For the first example, we have used while loop, and while loop it hasn't an option to create a limit to the iteration, but for this, for loop gives you an option to create the limit of the sequence. It means to create the number of iterations that you want. So the number of iterations are created over here. Let us create constant which contain the number of iterations that you want. Suppose that we want that our loop will iterate 10 times. It means it will iterate from 0 up to 9th iteration, and our loop will go, the iteration will come at the time interval of a half second. And the sequence, assume that the sequence between on and off of the red will be also a half second in order to maximize our time. Create constant of like 500 milliseconds. hope that is it. So for seeing how, if we really create, if the iteration doesn't go beyond 10 iteration, let us here create like an indicator to show us the number of iteration. Pull the indicator downward, sorry, Control Z, and need to pick only the indicator. So pick the indicator downward. Yeah, of course you should adjust its size in order to allow its visibility. Yeah, if we try to run this, if we try to run this, it doesn't work. Okay, I did 10 times. Why? Yeah, it is still in false. Let us assume that here is true, false, true, and then increase the timing of iteration, like at 1 second between iteration, 1000 milliseconds. And if you try to run, you will find that our loop is iterating. So why doesn't show us the number of iteration over here? We should see the number of iterations here. Why not doesn't show us the number of iteration? Yeah, sorry. The number of iteration, this comes as a duplicate. Let us delete this and bring this down. Yeah, of course, adjust its size and hit run. Yeah, 1 second, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. Then it stops automatically without needing the stop button, because we already set the number of iteration to 10. Yeah, the second, let us do the second way of, the third way of blinking the LED. Yeah, hoping that you are doing well. We are going to do the third way of blinking LED. As you see, we are removing the unwanted stuffs that will be not needed in the next session. There, of course, you click, right click, then you remove the sequence. There are that flat sequence because it is not needed. Remain the timing, also delete that. Of course, that local variable because it will not be needed. Yeah. Let us delete one timing because it will also not be needed. Of course, we are clearing the stuffs which will not be needed in the next session. Delete also that numeric indicator because it is not needed. Then remain with a Boolean RD. Go to loops, bring while loop. Of course, every sequence contains a looping. Looping is the repetition of sequence. Add the shift there. Yeah, there we create something like a logic variable. I think it is not found here. Let us move to Booleans where we'll find logic constant, which is, let's pick true. You may either use true or false. What the shift make is to shift between true and false. Yeah, delete that loose end in order to clear our work. pull the booleans in the proper positioning. So let us back to boolean and pick a not get. That will a not get the input. The output of not get is a complement of the input. It means it will shift between 0 and 1 and it also save the result. Yeah. Let us connect our LED. Then we are going to create something like a case structure. Of course, as the blinking of an LED contains two sequences as we see previously, it means high and low. We are going to control the case switching by using the output of the shift register. So add wait time, of course I go to timing and pick wait to time. Then let us assume that we are going to wait for like 5 seconds. Will be very high as we don't have time. Yeah, like 1 second. I think it is enough. That is a configuration of true. Let us do also the configuration of false in the same way, of course. Yeah, go to timing. Yeah, go to timing, then wait time to wait until next state. It means it will wait for time to wait until next state. It will wait also for 1000 milliseconds. You can also do to wait for different times between high and low of the LED according to your wish. Then let generate things like timing, like control button. Another that we may stop our loop according to our wish. Yeah, pull down the control button, adjust its size for proper appearance. Continue, let us learn and see. Yeah, you see that the LED blink as usual, but the timing between the sequence are generated, of course, according to the timing you set in milliseconds to that field. Yeah. I hope that you are doing well and you are enjoying the lesson. Let us see that you can do another configuration of controlling the button automatically. It means you are going to set which condition needed or the iteration needed, so that our loop will stop automatically without the effect of one self hand. It means of course the character of engineers include loving things of automation. I don't know why, but engineers, they are lazy somehow because they love things of automation, if I can say like that. Yeah, it means our loop will stop when the iteration goes above 10. Yeah, let's create a numeric indicator to see that what we do is true. Yeah, pull it down, adjust the size for proper appearance, as usual, let us zoom in a little bit for seeing where what we need. Yeah, hit run. Yeah, let us see. Yeah, the button on the control terminal will be released, and then the iteration stops automatically. Yeah, it means on the 11th iteration. Yeah, let us see if we use things like less than. In this way, the loop will continue. The LED will never blink. The button will still be released because the condition will still being false until the iteration goes above 11 times. It means we will wait for the condition, for the status of the output to change when it goes above 10, but it will consume our time. Let us use a less than symbol. Of course, the comparison operator already knows that it output a logic values. Yeah, then create and replace with the replace that items automatically with also a comparison palette, which is less than. You see that it inserted automatically without doing too much process. Yeah, you see that the iteration will bring until or state that gives a true value to the button and then stops. Yeah, I think we was together in this session. Let us next see how you can use the course you obtained in real-time mode. Yeah, next time we are going to see how you can use the way that we use in this session to control the real-time by using the way of blinking red. As you see, you find that the sequence of this real-time goes together with the blinking in virtual window. It means in the front panel. If you try to see where you find that at every sequence that our LED in front panel blink at the same time with that in real time using Arduino. So if we try to stop, before stopping, you see that I blink the red in virtual way. It means in a virtual instrument using the way of blinking a LED as the same as that we start with. Remember that we start with a sensor, multiply by 10 and compare with any number less than 10 so that the output will be high. When the output of the sensor multiplied by 10 goes above that of the sensor. So without delaying, let's click stop and make sure you subscribe, add a comment to the topic you wish that we will be talking in the next session, and don't forget to subscribe and share to your neighbor so that you should get all free knowledge. So stay in touch. of course don't forget to subscribe for always getting good idea. Thank you. Okay, if we click stop here, you see that it automatically stops, and that in Arduino stop blinking. Thank you. You see that the LED in virtual instrument is still in high mode, and also the LED in Arduino on Arduino board here is still in high mode. If we try to run again, okay, you see that the sequence begins as usual. Suppose let us stop in low mode while the LED is reading low, and see if the sequence will goes together with that in Arduino. Okay, let us stop by here. Okay, you see that this LED is off and this LED is off. This LED is reading 0 logic, and this is reading 0 logic. If we try to run again, yeah, you see that try to stop in high mode. Okay, sorry, I'm sorry. Sorry. Okay, if you have watched well, you find that when we stop in high mode, also the LED on Arduino will still also in high mode. So let's stop by here. Don't forget to subscribe and leave a comment below. Thank you.